Welcome back, everyone. This is the final video in my series, All the Logic Needed for Logic Games. And in this video, we're going to talk about translating conditionals that are expressed in everyday language into their logical meaning. And believe it or not, this is more complex than you might think, because often the semantic meaning of an expression can be quite different from the logical meaning of that expression. And for the logic game section, it's that logical meaning that you want to be clear about. Now, just to remind you, the standard form of a conditional looks like this. If P, then Q. But we're going to focus on two alternate forms for expressing the conditional. And these are the two most common natural language expressions used on the LSAT for applying a conditional in a non-standard way. And these are P unless Q and P only if Q. And just as in previous videos, we'll cover the quick guide memorization strategy first, and then we'll talk about the explanation and reasoning behind those strategies. Now, just as a reminder of terminology, and I know we've covered this in a previous video, but it helps to remind ourselves, if we have a conditional of if P then Q, then the P here, what follows the if, we call that the antecedent because it expresses the condition and literally it's what comes before. And Q here we call the consequent because it expresses the outcome. It's literally what comes after the antecedent. And those are the terms that I'm going to be using to talk about each element of the conditional. So let's get started. So if we have an expression like this, P unless Q, the diagram for this is actually very easy. And here's what you do. Take what comes before the unless and just drop it down. That's the antecedent. And negate it. And then take what comes after the unless, the Q, drop it down, that remains the consequent, form the conditional between those two, and that's it. It really is that simple. I'll give the explanation in a little bit, but when you encounter unless on the LSAT logic games, just take what's in front, drop it down and negate it, take the consequent, drop it down and leave it alone. Form the conditional, you're done. And of course, don't forget, take the contrapositive and remember that everything on the left can't be true together and everything on the right can. And there you go. So suppose, for example, we were to use this like an LSAT rule, and we said R is third unless T is fifth, for instance. And I'm just going to write out the unless, so that would be R3 unless T5. Drop down the R3, it remains the antecedent. Negate it, drop down the T5, it remains the consequent, leave it alone, form the conditional, and that's it. Take the contrapositive in the way that you've learned how to do that now, and of course, left side no, right side yes. And it's just that easy. Now let's cover only if. And just to be clear, P if Q is not the same as P only if Q. These are different expressions, but fortunately, P only if Q is quite simple. If you see P only if Q, take the P, drop it down, it remains the antecedent. Take the Q, drop it down, it remains the consequent, form the conditional, and you're done. Don't change a thing. And as you've probably noticed, you're absolutely right. P only if Q is logically equivalent to if P then Q. It's the same expression, it means the same thing. So when you see P only if Q, you can just take that only if and replace it with an arrow. If P then Q. And that's the quick guide. That's how to handle these expressions on the LSAT in a way that allows you to always be logically accurate with that expression. And as with other skills, I've included some practice, some homework, if you will, which you're welcome to complete. Make sure you complete or do your best with that before you take a look at the answers. And as usual, I've thrown in some curveballs and some references to other parts of these videos that we've talked about. So have some fun with that. But all right, let's turn to the reasoning now and see why it is that we can diagram these that way. Let's start with the unless. And I want you to bear in mind that I'm only providing reasoning for why we diagram the unless the way that we do. A fuller discussion of this phrase unless and its logical meanings I have in another video, and that will be a necessary video for you to watch prior to examining logical reasoning, but it isn't necessary for the LSAT logic games. But all right, let's imagine this in a natural language expression. Suppose I were to say to one of my students, you will not graduate unless you pass my course. What am I trying to say? What in an everyday sense does that statement mean? Well, I seem to want to say that if you want to graduate, you have to pass my course. That seems pretty straightforward. I mean, if I were to imagine a conversation with someone and I said to them, well, you won't graduate unless you pass my course, and they wanted to clarify to be sure they understand, it seems like that's what they would say. They would say, wait, okay, so if I want to graduate, then I have to pass your course? And I would say, yes, that seems an appropriate translation of that expression. And they might say, well, what if I don't pass? Then, of course, you don't graduate. And all of that seems intuitive and right. Because when I use the expression unless, I'm posing an exception. In other words, I'm saying that in every case, you're not going to graduate, except for one, namely that you pass my course. So if you want to graduate, in other words, if you want to change that default condition, then you have to activate that exception. You have to pass my course. Or you might find it easier to phrase it in the contrapositive. If you don't pass the course, in other words, if you don't activate that exception, then you will not graduate. Then the default condition will take hold. So if we were to phrase this in a transitional diagram, we might say, okay, not the case G, you will not graduate unless P, you pass my course. And we're going to apply what we saw in the quick guide. We're just going to change that not to a positive. You will not graduate becomes you will graduate. And P remains the same. We drop that down, you will pass. And so we diagram this the way it seems natural to understand that expression. If you want to graduate, then you have to pass the course. And the contrapositive seems to reinforce this, and some people find that easier. If you don't pass my course, then you will not graduate. I think that it's easiest to just drop down the antecedent and negate it, and then drop down the consequent and leave it alone and form that conditional the way I've outlined in the quick guide, because that captures the logical meaning of the unless every single time. Is that the only way to diagram the unless? As it turns out, no. But the diagramming complexities of the unless, I want to save that for another video because it goes beyond what you need in logic games. In logic games, it is simplest to simply diagram it the way I have outlined here, or diagram it according to the contrapositive. And the reasons why I explain in that other video on the unless. This is not just my arbitrary decision about how to diagram that expression. Although, if you want another way to understand this, you can simply translate unless as if not, because in every case that would capture this contrapositive of the expression that I'm giving you. So, you will not graduate unless you pass my course. Just change the unless to if not. If it is not the case that you pass my course. So in other words, if you do not pass my course, then you will not graduate. And that's equivalent to this second expression here at the bottom. If you don't pass my course, you won't graduate. Take the contrapositive and you get that initial expression. If you want to graduate, then you have to pass the course. All right, so let's turn to only if. We saw that the diagram for an only if statement is very simple. You just treat it like a normal conditional. And so now we want to explore why. Suppose that I had the expression, you can have ice cream only if you eat your veggies. And let's put the diagram for that right here. So what am I trying to say? Well, here's the problem. Most people's intuitive inclination is to interpret this statement to mean, if I eat my veggies, then I can get ice cream. And that would look like this. But if you remember from our discussion of the conditional, the statement, if I eat my veggies, then I can have ice cream, logically allows for the possibility that I could have ice cream even if I don't eat my vegetables. And I don't want to allow that because the only if stipulates a single condition here. It's not that eating my vegetables is one way that I could get ice cream. It's the only way. I should not be able to have ice cream without eating my veggies. So the reason why only if can cause trouble is because our immediate inclination about how to interpret that expression is often counter to how we should interpret that expression. So that when I say you can have ice cream only if you eat your veggies, our sort of immediate and intuitive understanding is to say, oh, okay, if I eat my veggies, then I can have ice cream. But that's not logically identical to that initial only if statement. And the reason why is because the only if expresses a single condition under which I can have ice cream. So it's easier to think of this in terms of a double negation. If you do not eat your veggies, then you do not get ice cream, because eating those veggies is the one condition that would lead to you having ice cream. To say you can have ice cream only if you eat your veggies means if you don't eat them, you don't get ice cream, which of course looks like this. And if we then interpret the contrapositive of that, it would be if you want ice cream, then you must eat your veggies, which looks like our original expression. That's one of the reasons why only if is fairly popular on the LSAT logic games, because if we just unthinkingly go with our intuition, most times we're going to want to interpret it incorrectly. So in this way, it's important to just remember that only if just states a standard conditional. You can have ice cream only if you eat your veggies means if you want ice cream, then you must eat your veggies. Let's look at one more example. Suppose I were to say, I will go to the party only if you go with me. Now again, intuitively, we might think, okay, so that means if you go with me, then I'll go to the party. But of course, that's not the logical meaning, because again, it allows that I might go to the party without you. If you go with me, then I'll go, but there might be other reasons that I go that don't include you. So instead, as before, think of this like two negations. If you don't go with me, then I'm not going to the party. And that means the same as, if I'm going to the party, then you're going with me. All right? Now again, the longer discussion of unless occurs in another video where I go into some of the details. However, on logic games, speed is to be prized. So when you see unless, just handle it the way we do in this quick guide. And if you're interested in the longer explanation, take a look at that other video. And of course, you will have to take a look at that other video before you get ready for logical reasoning, because there the LSAT is happy to use more complicated senses of unless. So good luck and thanks for watching.